What if I told you that for 15 hours, the internet as we know it just broke? I mean, Snapchat, gone. Can't log into Fortnite. Trying to binge that new show on Netflix? Forget about it. This isn't a hypothetical. This was the reality on October 20th, 2025, during the great AWS outage. Today, we're not just going to talk about what went down, we're going to break down how a single point of failure can cripple the world's biggest apps, and what you, as a founder or developer, can do to make sure you're not next. Welcome to AI Combinator. I'm Priscilla.
And I'm Alex.
Alex, it's great to have you. This outage was, it was massive. We're talking 16 million user reports, over 3,500 companies affected. This wasn't just a minor glitch, was it?
Not at all, Priscilla. This was a systemic shock. It was a stark reminder of how much of our digital world is built on a handful of foundational pillars. And when one of those pillars wobbles, the entire structure is at risk.
Exactly. And that's what we're digging into today. So for everyone listening, we're going to cover three critical things. First, we'll dissect the domino effect, how a tiny DNS issue in one data center in Virginia took down a huge chunk of the internet. Then, we'll uncover the myth of being multi-region and why so many companies who thought they were safe weren't.
And most importantly, we'll finish with an actionable framework, concrete steps you can take to build more resilient systems and protect your own applications from this kind of cascading failure.
I love it. Actionable advice is what we're all about. Okay, let's dive right in. Alex, take us to that morning. The reports start flying in, the internet is on fire, the official AWS report eventually points to a DNS resolution issue with a service called DynamoDB in the US East-1 region. For the founder who isn't a deep infrastructure engineer, what on earth does that actually mean?
It's a great question. And the analogy that's often used is the best one. Think of the domain name system, or DNS, as the internet's phone book. You know a name, like Netflix.com, and DNS looks up the number, the IP address, so your computer can connect.
Right, simple enough.
Now, imagine that same system exists inside AWS. Their services need to talk to each other. An application needs to talk to its database, DynamoDB, and to do that, it needs to look up its address. What happened here was that the phone book for DynamoDB, specifically in the US East-1 region, broke. The system couldn't find the number.
Wow, so it wasn't a hardware failure like servers catching on fire or a power cut. It was a software problem, a lookup failure, basically.
Precisely, and that's the first domino. DynamoDB is what's known as a foundational service. It's a massive, highly available database that countless applications, including many of AWS's own services, rely on to store critical information, user data, session information, application state, you name it. When apps couldn't find DynamoDB, they couldn't function. They couldn't retrieve user data, they couldn't process logins, they couldn't do anything.
And that's why everything from Snapchat to My McDonald's app suddenly stopped working. They all needed to look up something in that specific database, and the phone book was just gone.
Exactly. And then the second, larger domino falls. Other AWS services that themselves depend on DynamoDB in that region also started to fail. This created a cascading effect. A total of 113 different AWS services were impacted. The failure rippled outwards from that one initial DNS problem.
That is just... It's terrifying, the scale of that ripple effect, which brings us to the second point, the one I find most fascinating. A lot of founders probably heard outage in US East-1 and thought, whew, I'm safe. My app is hosted in Europe, or we run everything out of Oregon. But they weren't safe at all. Why?
This is, I would argue, the most critical lesson from this entire event. The concept is called control plane dependency. While AWS allows you to run your applications in data centers all over the world, that's the data plane, many of the core management services, the control plane, are centralized.
For your app, but you don't have redundancy for your cloud provider's own management tools.
And that's the blind spot for so many companies. They test for their own server failures, but they don't test for a regional failure of their provider's foundational services. It exposes a hidden dependency that most people are completely unaware of until it's too late.
Okay, so this is the part of the show everyone's been waiting for. We understand the problem, we see the hidden dangers. For the founders, the CTOs, the lead engineers listening right now who are probably breaking out in a cold sweat. What do we do? How do we build systems that can actually withstand this? Let's get into the actionable framework.
Absolutely. This isn't about abandoning the cloud. It's about using it more intelligently. There are three core pillars to building this kind of resilience. The first is architecting for true multi-region failover.
And by true, you mean more than just having servers in two places.
Yes, it means having a well-defined and, crucially, a well-tested plan to shift your traffic from a failing region to a healthy one. This could be an active-active setup where both regions are serving traffic simultaneously, or an active-passive one where a secondary region is on standby, ready to take over. The key is automation. The failover can't rely on a human getting a 3 a.m. alert and manually changing DNS settings, especially if the management console itself is down.
Right, because if the control plane in US East-1 is down, you might not even be able to log in to make the change.
Precisely. Your failover mechanism has to be independent of the thing that is failing. So number one is automated, tested, multi-region failover.
Okay, that makes sense. What's number two?
The second pillar is to perform a blast radius analysis. This is a term borrowed from failure engineering. You sit down with your team and you ask the hard questions. If US East 1 completely vanished off the face of the earth, what would happen to our application? You have to audit every single dependency, especially those global services we talked about.
So you map it all out. You'd ask, okay, our login uses IAM. What's our plan if IAM is degraded? Our file storage uses S3. What if its management plane is unavailable?
Exactly. And the answer might not be a full failover. It might be graceful degradation. For instance, maybe new users can't sign up, but existing logged-in users can still use the core features of your app. That's a much better user experience than a total white screen of death. The goal is to contain the blast radius of the failure, so it doesn't take down your entire operation.
I love that framing. It's not about achieving 100% uptime, which is impossible, but about limiting the damage when, not if, something fails. Okay, so we have automated failover and blast radius analysis. What's the third pillar?
The third pillar is not technical at all. It's communication. When your service is down, your users are in the dark. They're frustrated and they're hammering your support channels. You need a clear, pre-planned communication strategy.
The company status page.
Yes,
But with a critical caveat, your status page must be hosted on completely separate infrastructure, not just a different region of the same cloud provider, but ideally a different provider entirely or a specialized status page service. We saw many companies whose own status pages went down during the outage because they were hosted on, you guessed it, AWS.
Of course, that's such a classic mistake. Your "we're down" page goes down with the rest of your site.
It happens all the time. So have your status page hosted independently. Have pre-written communication templates for different outage scenarios. Be transparent, be quick, and tell users where they can get updates, like your Twitter feed. Managing user perception during a crisis is just as important as fixing the technical issue.
That is fantastic, Alex. So to recap the framework for everyone, 1, build for and test automated multi-region failover. 2, conduct a blast radius analysis to understand and contain your hidden dependencies. And 3, have an independent, robust communication plan ready to go before you ever need it.
That's the core of it. Resilience isn't a feature you add at the end. It's a principle you have to design for from the beginning.
Wow, this has been an incredible deep dive into what really happened during the great outage of 2025. I feel like we've moved from just understanding the problem to having a real playbook for how to defend against it.
That's the goal. These events are painful, but they're also immense learning opportunities for the entire industry.
Absolutely. Alex, as we wrap up, what's the one final thought you want to leave with the founders listening today?
It would be this. Don't treat your infrastructure as a utility that will always be there. Treat it as a dynamic system with inherent risks. Be proactively paranoid. Ask the what-if questions before they become what-now emergencies. The companies that survived this outage best were the ones who had prepared for failure long before it happened.
Be proactively paranoid. I love that. Perfect final thought. To everyone listening, thank you for tuning in to AI Combinator. Our question for you this week is, after listening to this, what do you think your company's biggest hidden dependency or single point of failure is? We'd love to hear your thoughts. Leave a comment on whatever platform you're listening on.
And if you found this breakdown valuable, be sure to subscribe so you don't miss our next episode.
Thanks again, Alex.
My pleasure, Priscilla.